Okay, so we're still working with this data plan example. And on the previous slide, we found the formula to model this relationship, which was the cost is 5 plus 2x. And so I plotted the points that we calculated in the table on these axes. And so notice here on the horizontal axis, we have the input, which is x, giving us how many gigabytes we used. And on the vertical axis, we have the output, which is C, the cost in dollars. And so I plotted those points that we calculated in the table, and if we draw the curve through those points, we can see that actually the curve is a straight line, and the steepness, the slope of this curve isn't changing. So this is an example of a linear function. And so for linear functions such as this one, we've got two really important parameters in the model that are going to describe the relationship between the two variables. So one of them is represented with this blue 5 over here. So remember, this 5 corresponded to the flat fee that you pay each month. So this is like the fixed cost that you pay. Graphically, we can see that represented over here on the vertical axis. The graph starts at when x is equal to 0, c is equal to 5. So this point where the graph crosses the vertical axis we call the vertical intercept. And that we typically would express as coordinates of a point. So here we would say the vertical intercept of this graph is at the point 0, 5. And practically speaking, it tells us what is the value of the output when the input is 0. So in this case, it would tell us that if we don't use any data, we're going to pay $5 flat fee. So we call that the vertical intercept. The other important parameter would be the 2 in this formula. And so whereas the 5 tells us where the graph starts, this parameter 2 we call the slope of the graph. And it tells us that the cost is going to increase by $2 every time we increase our data usage by 1 unit, by 1 gigabyte. So it's telling us the rate of change. And for linear functions, what's special is that this rate of change is constant. So no matter which two pair of points you pick, the slope connecting those 2 points is going to be the same. Okay, and this is why the graph is shaped like a line. So the slope isn't changing no matter which 2 pair of points that we pick. So to find the slope in general, let's take a look at what that formula would look like, and then we can attach some meaning to these symbols using the graph above. So in general, the slope is equal to the change in the output. And if you're looking at this formula down here, let me just explain what this notation means. This triangle is actually the Greek letter delta, capital delta, and in mathematics we use this to represent change. So we use the D to mean difference. So that delta C means change in C, and similarly this would mean change in X. In any case, looking at the graph up here, let's pick 2 points. So let's say we have a point over here at the coordinates of this, x is equal to 4, and we calculated that that cost was $13 a month. So this is our initial point that we're taking. So we're going to call this, in general, it has coordinates x0, f of x 0. And then we can pick any other second point. So let's say we pick the point over here, and this point had coordinates 12. If we use 12 gigabytes, then the cost is $29. And this second point, this is the one that has coordinates x1, f of x1 in general. And now what we want to do is calculate the slope between these 2 points. And that we can calculate by figuring out what is our change in x. And visually, that change in x is this horizontal distance that I just drew. And in this case, we would say that distance is going to equal 12 minus 4. So that would be, if we started with 4 gigabytes and all of a sudden we increased to 12 gigabytes, that's a change in X of 8 gigabytes. And in general, we can take and calculate this change by taking X1 minus X0. And for the rise, we can do a similar calculation with the y coordinates. So here the rise is going to be how much did the cost change. So the change in the cost would be, well, we started with a cost of $13, and when we increased to 12 gigabytes, the cost went up to $29. So altogether, if we go from $13 to $29, that's an increase in the cost of $16. And generally speaking, that's where this f of x1 comes from. That was our 29, and f of x0 was the 13. So we take the difference in our outputs. And what's important in this calculation is notice that what comes first in both of these differences are the coordinates of the second point that we have here. And what we subtract from that are the coordinates of the initial point that we have. So in both these cases, I take f of x1 minus f of x0. And in this case, I take x1 minus x0. We want to be sure that we have the differences in a consistent way. And so to finish this calculation up using the formula down here at the bottom, what we've got is, if I take my f of x1 minus f of x0, that was all of this quantity over here, and that was a total increase in cost of $16. And then I can take and calculate the run by looking at x1 minus x0, which in this case is 12 minus 4, which gives us the 8. And notice that this ratio comes out to $2 per gigabyte, which matches the slope that we have in our formula. So to calculate the slope, we can pick any 2 points and calculate the change in the outputs divided by the change in the inputs. And so to generalize the previous example, the previous data plan example, what makes linear functions special is that they have a constant rate of change. And when that's the case, any linear function we can express in what is called the slope-intercept form, which takes the form of y is equal to b plus mx. So in this case, it's important to note that x is a variable, y is a variable. These are both indicated in black font. B and m are parameters of this model. So this is going to be some constant that we find. And where are we going to find that constant? That value for b we're going to get by figuring out what is the value of the output when the input is equal to 0. And the second parameter is the slope m, and we can find the slope by calculating the change in the output divided by the change in the input. And in general, the practical interpretation of that is it's going to tell us how much the output is going to change each time we increase the input by 1 unit. So this slide here is really the main summary of this section in 1.2. So let's take a look at another example before I head you off to try taking a quiz before we come to class.